NeuroBlu is a data and analytics platform that enables uniquely powerful evidence generation for behavioural health. With the most robust database of its kind and seamless AI-powered analytic tools, NeuroBlu allows users to unlock insights in behavioural health data like never before. There is a huge gap in evidence in behavioural health. Despite decades of research, we still do not know how to alleviate most behavioural health disorders. We need new solutions, and we need them now. NeuroBlu makes new insights possible so that we can reinvent behavioural health. NeuroBlu is powered by the only database of its kind, with over 50 million rows of data for over 500,000 unique lives, spanning 20 years of longitudinal data and most major psychiatric disorders. Clinical data is enriched with our proprietary NLP algorithms, which translate unstructured clinician notes into keywords that can be used for analysis on important factors not typically captured in clinical data, such as symptoms, side effects, and external stressors. We also have quantitative outcome measures that track patient function and disease severity over time, giving users the power to track the efficacy of different treatments and the impact of demographic factors on disease outcomes. NeuroBlu was designed with user-friendly tools that streamline the difficult, manual and error-prone steps of analysing data. This means you can get insights and publish papers without spending hours cleaning data and troubleshooting code. We have a built-in library of code templates that let you use data with ease, and a coding interface that lets you create your own R or Python code as needed. I'll now give you a quick tour of the NeuroBlu platform and show you what it can do. First of all, NeuroBlu is a cloud-based platform. Through a secured login, you can access the inbuilt database and analytics tools designed to accelerate the process of analysing real-world data, and you can generate evidence for publication with less time and effort. So let's log in first. Once you log in, the dashboard provides a view of the projects you have running in 3 different tools: the R code module, the Cohort Builder, and the category map. Other things you can see on this screen are the Data Explorer that lets you look at the dataset, and the user manual and technical support information. So, dataset specifications gives you a very detailed understanding of what's in the dataset, the kind of information you can find, and how it's structured. You can also browse the data. This gives you a summary of the statistical features of the dataset, for example the age distribution, gender, and other demographic information about the patients, how much data there is in terms of time for each patient, and the number of visits, what disorder groups are represented in the dataset, and what the most common drugs are. So you can see that substance-related disorders and major depressive disorder are the most common types, and the most commonly prescribed drugs are trazodone, quetiapine, and clonazepam. The Data Explorer also lets you see the detailed structure of the data tables, although of course you can only see the first 50 rows and the data is anonymised. So for example, this table is the person table that shows you the basic information about each person or patient that is represented in the database. There's full online documentation including a user manual, FAQ, and information about the particular packages that are included in the project. So for example, if you're an R programmer, there are a suite of packages that allow you to work with the dataset, including the NeuroBlu package that gives you lots of convenience functions for accessing the data. Blue Suite is our advanced analytics package and includes ServeBlu, which is for survival analysis, and CompEffectBlu, which is for comparative effects analysis. So returning to the dashboard, let's look at what you can do with the Cohort Builder. We'll create a new cohort. This interactive cohort creation process lets you understand how the changes you make to the inclusion and exclusion criteria affect the size and the demographics of the patient group. You give the cohort a name and you specify the dataset it's going to be based on. So we've now created a cohort that includes all the patients. At the moment, this dataset is 562,940 patients, and you can see on the right some basic demographic information about the patients, including age, gender, race, plus information about how much data there is on each patient and their CGI severity score. So let's add some terms to specify the kind of patient you want to look at. So for example, suppose we only want to look at adult patients of working age. So there must be at least 18, but also we want ones that are under 65. And you can see immediately that we have a smaller patient count, as you'd expect, and we have a narrower age distribution because of the criteria we've specified. Perhaps more interesting, we could look at something like the drug they're being treated with. So for example, if we were interested in trazodone, which we know is one of the most common drugs, we can just select that. And now we're down to a specific patient group of 36,108 people. And suppose we only want to look at the most severe patients, people who presented with a CGI severity score of 5. So now we're down to under 10,000 people. And as you'd expect, everybody has a baseline CGI-S of 5 or greater. You can also remove criteria you think are superfluous. Let's look at another form of diagnosis. So for example, if we're interested in patients with ADHD, and again we can dynamically see how the patient population changes in response to the criteria. And of course, although I haven't shown it, you can also have exclusion criteria. Once you've created your cohort, you can then use it in your R code to perform a more detailed analysis. Okay, now let's look at what you can do with the R code module. The module comes with several examples and templates that you can use to get you started on developing your own projects. So for example, here's a demo example that lets you visualize individual patient journeys and plot those patient journeys in a graphical, easy to understand way. So you can see there's a number of panes within the R code module. This one lists all your files. So for example, here's your main script, which appears in your code. And so you can see your R code, which you can then either run a line at a time using the run button, or you can run the whole thing using the source button. And I'll run this now. And you can see that's run very quickly, it's already complete. And down here you can see the graphical output from your program. So here's an example of an individual patient journey showing the kind of level of detail that's available in the dataset. So for example, here's some brief demographics. The patient is a 50-year-old white male from Virginia. And at the top here you can see the events in their treatment history. So you can see when they were hospitalized and when they were diagnosed, in this case with major depressive disorder. This graph shows their CGI severity score. So you can see a point plotted for every recording that was made, and the blue line is a smoothed and interpolated trajectory of their CGI severity scores, because as you'd expect with such a subjective assessment, there can be a lot of day-to-day variability and variability depending upon who's made the assessment. And down the bottom you can see in great detail what medications the patient has been on and at what times, and obviously you can then correlate this with their CGI severity trajectory, hospitalizations and other events. Now let's look at another example where we use NeuroBlu to compare outcomes with two particular drugs for major depressive disorder. As you can see in the output viewer window here, we're comparing the results of the treatment of duloxetine and fluoxetine. So you've got a brief summary of the dataset, and perhaps more interestingly, you can plot the outcome. So what we're plotting here is the difference in the CGI severity score up to 12 weeks of treatment with the two drugs. And you can see that actually fluoxetine is doing slightly better than duloxetine in that there are more patients who are seeing a 1-point decrease in their severity score than there are with duloxetine. One of the most exciting features of the NeuroBlu dataset is the ability to make use of data that's present as unstructured notes but has been turned into structured information using natural language processing. And that enables you to ask all kinds of really complex questions of the dataset. Look at the dataset specifications. The stressor information that comes from the clinician notes is recorded in this format with a number of categories including academic, environment, family, financial, housing, legal, occupational, personal and social issues, with a number of headings under each category. And in each category, each item is identified as being either a negative or a positive effect. So let's look at how we could use that information in our R code to look at, for example, bereavement. So what I've done here is I've written a relatively short piece of R code which selects patients with major depressive disorder, gets the stressor information for those patients, and then we look for those patients who had a stressor label of bereavement in their data. And I also looked at just those who had family issues as a category. So the most simple question to ask is how many of those patients are there? So let's run the analysis and we'll see the results displayed down the bottom here. So you can see that took under 30 seconds to process that massive data set. And so of the 129,120 patients who've been diagnosed with major depressive disorder, there were 9,844 who had the report of bereavement, so that's 7.6% of the dataset. And of that same dataset, 559,806 patients, or 46.3%, had reported family stressors. Obviously, this is a very straightforward analysis we've done here. Once you've isolated and identified those patients, you can then go on to perform further analyses. So, for example, you could compare their CGI severity scores. You could look at what drugs they're treated with. You could look at their outcomes.
Holmusk is inviting applications for the NeuroBlu Award, an opportunity worth €50,000 that gives you free access to the world's largest real-world dataset in mental and behavioural health, and the analytics power to interrogate it. Are you a startup developing products in mental health? Do you need real-world data to understand how your product might work in the clinic? Or are you an academic doing mental health research with a track record of using clinical data to answer your questions? If the answer to either question is yes, we'd love to see your proposal for a project you could deliver using our platform. With data on the mental health journeys of more than 500,000 patients, what insights could you gain? The NeuroBlu Award gives you a free 6-month subscription to the NeuroBlu platform, technical support, and an honorarium of €3,000 to support your research. In return, we simply ask that you tell us what you learned from the platform and participate in some publicity activities. The application process is very straightforward. Simply fill out an online form with a description of your proposed research project and submit it to us before the deadline. If your idea is shortlisted, we'll set up a call to discuss it in more detail. Then, if your proposal is ranked top by our team of experts, we'll get back in touch with you to set up your award. Visit this link for more information on the award, or get in touch at this email address.